Hello, you are on the DevVibe channel, and in this video, we will discuss what testing in Flutter is and write tests based on a real application example. We will write tests for the Cherify app, which we developed from scratch in the previous video. Before we start, let's briefly review what testing is and the types of testing that exist. Testing is the process of verifying software to identify errors, ensure all functions work correctly, and improve the product's quality. Imagine you are working on a large application with a team of developers. Testing provides confidence that adding new code or features won't break existing functionality. Without testing, you would have to manually check the entire application after each change, which would take an enormous amount of time and resources. Flutter has three main types of tests. 1. Unit tests. These test individual functions or methods. They are ideal for verifying business logic. Example: ensuring that a discount calculation method works correctly. 2nd, widget tests. These test the user interface for errors. Example: ensuring that pressing a button opens the correct screen. 3rd, integration tests. These test the entire application from start to finish. Example: ensuring that a user can successfully register. In this video, we will write unit tests as well as tests for blocks. We'll start by importing dependencies. Let's import the Mockito library. Mockito is a library for creating mock objects in tests, allowing you to emulate dependency behavior. It is used to isolate the code being tested, speed up tests, and simulate various scenarios, including errors. We'll also import the Bloc test library. For our tests, we will use mock objects, so let's create a special class for this purpose. In it, we will create our objects with test values. First, we create a user object. Then, we create an object for a list of categories. Next, we create an object for a single category. We do the same for applications. After this, we create objects for errors that we will simulate. Now that we have created the test stubs, let's start writing tests. We'll begin by testing the user block. Create a new file in the test folder. First, declare the main function, which will be the entry point for the test. Here, we will test our user block. As we remember, our block has dependencies such as auth repository and user repository. For testing, we will create mock classes. To do this, we need to use a special annotation, generate mocks, to which we pass the classes that need to be generated. To start the generation, run the following command in the terminal. After some time, we will see a file created in the same location. Now, let's declare variables with the late keyword for our repositories, as well as for our block. Next, we need to call the setup method. passing it an anonymous function to initialize the necessary objects or settings before each test. This helps avoid code duplication and ensures a clean environment for test execution. Here, we assign our variables the generated mock objects. We also create the block, passing the required dependencies to it. After the setup method, we need to call the teardown method to clean up and release resources after each test. This is important to prevent memory leaks and ensure test isolation, guaranteeing that each test starts with a clean state. Thus, we have initialized the testing environment. Now, let's start writing the tests themselves. To do this, we call the block test method. In it, we specify the generic for our block and the state. The first parameter is the description of the test. For example, we want to test that when Google Sign-In is successful, our block will emit a success status. Then, we pass the build parameter. Here, we will configure the behavior of our mock objects and return our block. This is also an anonymous function. Since our repositories are mock objects, they have no implementation. Therefore, we need to specify the behavior ourselves when certain methods are called. For this, we call the when method. In this method, we specify which method we want to configure. In this case, let's configure the sign-in with Google method of our repository. After this, we call the then_answer method. In this method, we must pass an anonymous function that will return something. In this case, we want to test a scenario where our repository successfully logs in and thus returns a write value with our test user. Also, don't forget about async, as we need a future write value. After this, we return our block. Thus, we have written the build method. Next, we need to pass the act parameter. This is also an anonymous function where we perform the action being tested. In this case, since we are testing Google Sign-In, we will add the corresponding event to the block. Next, the final part, where we compare the result with the expected one. To do this, we pass the expect parameter, which is also an anonymous function in which we must return a list of states. This list represents the sequence of states that our block will emit after our act, in other words, after adding our event. We assume that the initial state will have a loading status. We pass an instance of our state created through the initial constructor, and immediately call the copy with method to specify the status. After this, we assume that our block will emit a state with a success status and the received user. This will be the same user that our mock repository will return. Note that tests use object comparison, so we need to use the equatable library. Let's do this for our user class. We need to pass a list of all the fields from the class. We will have to inherit from it in every class we compare. The user state class also requires this. Thus, we have written the first test. In it, we configure the behavior of our mock repository so that it returns a write value. Then, we add the event for Google Sign-In. After this, we check the result with the expected values. For this, we pass a list of states that should match in sequence. Now, let's run our test. For this, we execute the Flutter test command. As we can see, the test passed, which means this method is implemented correctly. Now, let's write a test for a scenario where our repository returns an error. We'll create another description. This time, the method in build will be configured differently. In the then_answer method, we will return left as we are simulating an error. We'll pass our auth failure to it. The act method remains the same because we're testing the same method, but the repository behavior changes. Since different states are expected for an error, the expect method will return a different list. The first state is expected to be loading, followed by one with an error status. Additionally, it should contain an error message identical to the error field from our auth failure. Thus, we've written another test for our event, but this one simulates a failure. Let's run our tests. As we can see, both tests pass successfully. Next, we'll write tests for another event in our block, specifically for fetching the user. It's similar. First, we'll write a test for a successful repository response. Note that this time, in the when method, we configure the user repository and its getUser method. When this method is called, it will return a write value with our test user. In the act parameter, we'll add our event for fetching the user to the block. In the expect parameter, we'll return a list of expected states. First, it will be a loading state, followed by a successful state with our user. Next, let's write a test for the scenario where the repository returns a failure. Again, everything is the same, but the when and expect parameters differ. Here, when will return a left value with an error. And in expect, we'll expect a state with an error status. Next, let's write tests for the logout event. First, we'll write a test for when the logout from the repository is successful. Configure the method to return a write value with null, as it doesn't accept any value. It's essentially a void method. In the act method, call the corresponding event. In the expect parameter, return the expected statuses. First loading, then logout. Finally, the last test for this block is a scenario where the logout returns an error. Again, in the when method, we'll return a left, and in expect, we'll expect an error state. Let's run our tests. As we can see, all tests pass. Now, let's examine how to write tests for a repository. Create a file for testing the application repository. Also, declare the main method. Our application repository depends on the application remote data source. Therefore, we need to declare our method with an annotation and pass the application remote data source class to generate a mock for it. Run the command for this. Afterward, declare two late variables, one for the dependency and one for the repository itself. Then, as in the previous test, call the setup method. Here, assign our data source variable the generated class. Additionally, create repository MPL, passing the dependency into it. Now, let's start writing the test itself. Unlike block testing, a different approach is used here. We call the test method. Just as before, we pass the test description to it. In this case, we want to test that we successfully fetch a list of applications if the data source returns a successful value. Then, we pass an anonymous function where the test will occur. As before, start by configuring our mock class. For this, call the when method. Here, pass the method for fetching applications. Note that it accepts named parameters. However, we want to configure this method to behave the same regardless of the parameters passed. To do this, use the anyNamed method and pass it the parameter name. This way, when this method is called, regardless of the parameter value, it will behave consistently. For unnamed parameters, simply use the any method. If we wanted to configure this method to work only in specific cases, we'd pass the desired parameter value. Thus, within this test, Flutter understands that we want to simulate the method's behavior under certain conditions. In this case, we configure the method for all parameters, so we pass any named everywhere, specifying parameter names. As a response, return a list of test applications. Note that write is not used here since the value is returned from the data source, not the repository. After configuring the data source behavior, perform the test action. Call the repository method and pass any parameters. Once the action is completed, verify its result. Use the expect method. First, ensure the result type is right. To do this, first pass the expected value, then the isA method. Pass the type as a generic. This verifies that our result is of type right, indicating success. Next, check the value of right using expect. Explicitly cast to right, then extract the value. Check its equality with the applications list. Finally, verify that the data source method is called only once. For this, use the following syntax. Call the verify method and pass it the method call with the same parameters. Then, call the called method and pass the expected number of calls, 1 in this case. Now, let's write a test for fetching the list when the data source throws an exception. Copy the first test and modify its contents. Start by changing the description. Then, replace the thenAnswer method with thenThrow. This method simulates an exception. Here, pass a dio exception. Create an object and provide the response parameter. Simulate the status code, request options, and the response itself. In this case, simulate a server message providing a detailed error description. Next, perform the action. Call the method. Then, verify results. Here, expect the type to be left, not right. Also, expect the left value type to be application failure. Finally, check the error message. It should match the one specified in dio exception. Lastly, verify that this method is called once. Run the tests and check the results. As we can see, all tests pass successfully. For homework, try writing tests for the remaining parts of this repository, specifically for fetching an application by ID. The code link will be in the video description. Now, let's look at testing more complex behavior, such as the main block. Create a new file. Also, declare the main and write annotations listing the dependencies for our block. After this, declare late variables. In the setup method, assign them values using generated mocks. After this, in the teardown method, close our block. We'll test the Load Applications event. First, test the behavior when there are no categories in the state. In this case, it shouldn't emit anything and should simply halt the method execution. For this, call the block test method and pass generics. In the build method, simply return our block. In the act method, add the event to our block. In the expect parameter, return an empty list, as we expect nothing when categories are not loaded. Run this test. As we can see, the last test failed. The issue lies in the condition set in our block. If categories is null, the condition should use true, not false, so it evaluates as true, and the return is executed. Let's try running the test again. As we can see, everything works. Now, let's write a test for a situation where we have categories in the state. In this case, in the block method, we need to configure it so that when the method for fetching applications is called, regardless of the parameters, it returns a list of our applications. Next, we manually add categories to our state. We can do this using the emit method. The act parameter remains unchanged. Now, we need to modify expect. Here's where it gets interesting. Firstly, the first expected state is a state with a loading status, a list of categories, and the urgent filter, which defaults to false. Next, if we observe, when the refresh parameter passed to the block is true, all collections and pages are reset. Accordingly, the next state will be the same as the previous one but with empty collections instead of null collections. Then we get into the logic of fetching applications. Initially, there is a loop where we iterate over the categories in the state and make requests with a filter for each category. Upon a successful request, we emit a state with an updated map of categories and applications and an incremented categories page. Thus, duplicate the previous state, modifying its map and categories page. We can immediately add another state because we know there are two categories, and a request will be made for each one, resulting in an emit. Don't forget to increment the page as well. Since there are only two categories, after this our block will simply fetch a list of the latest applications and emit them into the last applications field, while incrementing the applications page. So we can immediately add the corresponding state. Here's the code fragment where our block adds the last applications and increments the page. Thus, there are 5 sequential expected states in the test, given that there are 2 categories. Let's run our test. As we can see, it failed. The issue is that we need to inherit from equatable in our main state class because we're comparing it. Let's run the code again. This time, as we can see, all tests passed. Thus, today we explored what testing is, why it's needed, and covered some parts of our application with tests. Of course, fully testing the entire application would take considerable time. I suggest that, for practice, you cover another part of the application with tests, such as the event for fetching categories. If this video was helpful to you, make sure to like it and subscribe to the channel. If you have any questions, don't hesitate to leave them in the comments below the video. I'll gladly create separate videos to explain the topics you're interested in more thoroughly. If you liked the video, don't forget to like and subscribe to the channel so you don't miss new episodes. Thank you for being with me, and see you in the next videos.